Determine whether the series converges conditionally or absolutely or diverges. So let's look at the first example. We have the sum from n equals 1 to infinity, negative 1 to the n plus 1 times n squared over n plus 1 squared. For this one, I'm going to take the limit first. And the reason I'm going to do that is because in the top, I basically have n squared. And the bottom, I also have an n squared as the highest degree. So that's going to cancel and we're going to get 1 as a limit. So let's write this out. I have n squared over n plus 1 squared. Because they both have an exponent of 2, I can actually factor that out. And I'll have n over n plus 1 in parentheses and then square the square outside. And then I can divide the inside by n. So everything will be divided by n. So it will give us 1 over 1 plus 1 over n. The 1 over n is going to go to 0. And so you really have 1 squared, which is 1. The limit does not go to 0. Therefore, by the nth term test, this diverges. So it diverges if we take the absolute value, and diverges if we don't take the absolute value. And the reason is for the without absolute value is because of the alternating series test. So this doesn't satisfy the limit going to 0. In the next example, we have the sum from n equals 2 to infinity, negative 1 to the n over n times ln of n. So this one is an alternating series, so we're going to look at the 3 conditions. So first we have to check that it's positive, so we have 1 over n times ln of n. And here we're plugging 2 to infinity, so ln of, I guess the only issue is ln of n, and ln of 1 is 0. So, ln 1 is 0, so, 2 and above, that's obviously positive. So, yeah, this is met. It's decreasing. Well, whenever you look at 1 over n times ln of n, clearly the denominator is much bigger than 1. So, yeah, this is definitely true. So if the denominator is bigger than the numerator, your function or series or sequence is going to be decreasing. And the limit does go to 0 as n approaches infinity. So that's pretty obvious. Okay, so all conditions are met. Therefore, this converges conditionally. Okay, so now we have to look if it converges absolutely. And for the convergence absolutely, we have to take the absolute value. So really, we're going to take the absolute value of negative 1 to the n over n times ln of n. And all that does is make it positive. So we can get rid of this negative term, like alternating negative term. So that turns into 1 over n times ln of n from n equals 2 to infinity. So for this, I would use the integral test. And because the conditions satisfy, these 3 conditions are satisfied, then we can also use the integral test. So we have 1 over n times ln of n dn. We have to integrate this, so we're going to let u be ln of n, du be 1 over n dn. So now I can rewrite this integral in terms of u. So these limits are in terms of n. Now when n is 2, u is ln of 2. As n approaches infinity, u also approaches infinity. And so inside I have du over u, which is ln of u, and that goes from ln of 2 to infinity. This is an improper integral, and technically you have to use a limit, but if I let u approach infinity, ln of u also approaches infinity. So this is infinite, and by the integral test, it diverges. So this does not converge absolutely, but it does converge conditionally. Let's look at the next example. We have the sum from n equals 1 to infinity, cosine of n pi over n squared. Now this cosine n pi looks strange, but all you're really doing, so let's see, we're starting at cosine n pi. Well, n is 1, so that's cosine of pi, which is negative 1, and then going cosine of 2 pi, which is 1. So you start at negative 1, go to 1, and you just jump back and forth. Okay. So this shows you that it's alternating, and then n squared is always positive. So we have to look at the three conditions. Positive, decreasing, and limit goes to 0. We have to look at 1 over n squared, so we ignore the alternating part. 1 over n squared is obviously positive. Is it decreasing? Well, yeah, the denominator is getting bigger and bigger, and the numerator is just staying the same, which is 1. Is it going to 0? Well, yeah, the limit as n approaches infinity of 1 over n squared is definitely 0. So by the alternating series test, this converges. Now we have to look if it converges absolutely. So we want to take the absolute value of this sequence. And what the absolute value does is make this positive. So we could just remove that and put a 1 instead. And we know that this converges because of the p-test. So we conclude that it converges absolutely. So it converges with the absolute value and it converges without the absolute value.